In case 3, the denominator has irreducible quadratic factors, none of which is repeated. Okay, so you're starting out with some single fraction that's p of x over q of x. So q of x is the denominator here. Okay, so you need to look at its factorization. Okay, so when you factor the denominator, what's going to happen here is you may have a quadratic factor. Okay, so if it's a quadratic factor, your factor is going to have the form ax squared plus bx plus c. It is going to be irreducible, meaning you cannot break it down any further. It doesn't factor any further. Okay, so you're going to have a quadratic irreducible factor, and none of them are repeated. Okay, so now we're getting into this situation. Keep in mind, even though you have a quadratic factor in the denominator, you can still have a linear factor as well. Okay, things are starting to mix. Okay, so let's talk about the quadratic factor. Suppose the complete factorization of q of x, which is the denominator of the original fraction, contains the quadratic factor ax squared plus bx plus c, which cannot be factored further. Then corresponding to this quadratic factor, the partial fraction decomposition is going to contain this term. Okay, so what you're going to do is that you're going to take your quadratic factor, and you're going to have one fraction because it's not repeated. Okay, so whatever that factor is, it will be the denominator. It is going to be degree 2. So in the numerator, you need to write something of degree 1. Okay, so you're going to have, instead of just a single number, which is degree 0, now you're going to have a degree 1 polynomial. So it's going to have the form ax plus b, and you're going to have to figure out what the a and the b are. Okay, so that's how you're going to handle an irreducible quadratic factor that's not repeated. Okay, in example 3, you're going to have a quadratic factor as well as a linear factor. So we're going to talk about how to mix the two. Okay, so example 3 says find the partial fraction decomposition for the given rational expression. We have 8x squared plus 10x minus 3 over x plus 4 times the quantity x squared plus 1. All right, first thing we need to do is compare the degree of the numerator to the degree of the denominator. Okay, the degree of the numerator is 2. The highest power of x is 2, so this is degree 2. And then the bottom, if you look at it, if you were to FOIL this out, you would get x squared times x. That's going to give you an x cubed. And then this will be x plus 4x squared plus 4. And so the highest power of x is going to be 3. So the bottom is degree 3. We do have this situation where the degree of the numerator is less than the degree of the denominator. So this is going to fall into one of the cases. Okay, we have to talk about which case this is. Okay, the denominator is already factored for us. I mean, if you look at this, you could try to factor the x squared plus 1 further. So let's talk about that. If you have x squared plus 1, you might try to break this down into x squared factors into x and x. 1 breaks down into 1 times 1. If you try to factor this, no matter how you adjust the signs, it's not going to multiply out to give you x squared plus 1. This is a sum of squares. A sum of squares does not factor. If you had the difference of squares, like if this had been an x squared minus 1, then that would factor. Okay, but as it's written, it does not factor further. Okay, so let's talk about the denominator here. Okay, so we have an x plus 4 times an x squared plus 1. Okay, this is a linear factor. Okay, x plus 4, the highest power of x is 1. Okay, so that's a linear factor. When I look at x squared plus 1, the highest power of x is 2. This is a quadratic factor. Okay, do not do this. Okay, x squared plus 1 is not the same thing as x plus 1 squared. These are two different things. When you look at x squared plus 1, the square is actually on the x itself. That makes this quadratic. When you look at x plus 1 in parentheses, squared, yes, if you multiplied it out, you would get something quadratic. However, from a factorization standpoint, this is linear inside the parentheses. So this would be a repeated linear factor because it's x plus 1, which is linear, times itself. Okay, so this would be a repeated linear factor. You absolutely have to understand the difference between the two when something is quadratic and when something is repeated linear. Okay, please understand the difference there. If you don't understand, ask me. Okay, all right, so here we go. I am going to rewrite what I started with. Okay, so we're starting with 8x squared plus 10x minus 3 over this denominator here. Okay, so we've talked about the denominators. They cannot be factored further. Okay, denominator can't be factored further. So it's time to set up the partial fraction decomposition. We are trying to break this single fraction up into simpler fractions that we are adding or subtracting. Okay, so we have to handle it one factor at a time. I am going to start with the linear factor. Okay, the linear factor is not repeated, so we only need one fraction for it. Okay, x plus 4 will go in the denominator. The denominator is degree 1, so the numerator, we need to go down to degree 0. It's just going to be a single number. Okay, then we're going to add the next fraction. Okay, we move on to the other factor because the linear factor was not repeated. The other factor is x squared plus 1. It is quadratic. It is also not repeated. If it were repeated, you would see x squared plus 1, which is quadratic inside the parentheses, and you would have a power out here. That's not what you have, okay? This is quadratic. It is not repeated, okay? So the denominator is going to be degree 2, so that means in the numerator, you have to put something that's degree 1. So it's going to have the form mx plus b, okay? So as far as our coefficients go, we've already used an a, so I'm going to put bx plus c, okay? And then that's it. You don't need another fraction because the quadratic guy isn't raised to a power, okay? So you would stop where we are. This is what the partial fraction decomposition is going to look like, okay? We need to figure out what the a, the b, and the c are, okay? All right, so here we go. In the next step, we're going to try to get rid of the fractions, okay? So let me rewrite everything we have. So let me rewrite this guy. You may be wondering about the numerator, like why I didn't do anything with it. You can, it just may create extra work. I wouldn't do anything until you absolutely have to do it when you're doing this process. Okay, so let me write this stuff out. I need to give myself some extra room because we're going to be multiplying by stuff to get rid of the fractions. So let's see. Okay, here we go. I want to get rid of the fractions. So on the left side here, I'm going to multiply by the entire denominator x plus 4 times x squared plus 1. Okay, if I do it to the left side of the equation, I have to do it to the entire right side. So each of these pieces are going to have to get multiplied by x plus 4 times x squared plus 1, or multiply it here and then here. And now we'll go and clean everything up. Okay, so we're going to have, let's see, if we go back to the left side of the equation, okay, x plus 4 cancels with x plus 4, x squared plus 1 cancels with x squared plus 1. This is going to leave me with 8x squared plus 10x minus 3, okay. And then we'll go to the a term. In the bottom, we have an x plus 4. That cancels with the x plus 4 in the top. This is going to leave us with a times x squared plus 1. We'll keep the plus sign in the middle. This matches this. And then on the b part, we have an x squared plus 1 in the bottom that cancels with the 1 in the top. So be careful here. We're going to be left with the entire quantity bx plus c. So put that in parentheses. All of that is going to be multiplied by all of x plus 4. Okay? Fractions are gone, and we're going to have to clean this up. Okay? All right, so here we go. I'm not going to do anything to the left side because it's in the format ax squared plus bx plus c. Okay? Multiply out the right side. Okay, so here we need to distribute the a. So we're going to get ax squared plus a. And then we have to FOIL out this other part. Okay, so we're going to get bx times x. This is going to be plus bx squared. And then this is going to give us 4 times bx. And then the inner terms is going to give us plus cx. And then the last terms are going to give us 4 times c. Okay, so now we're going to reorganize the right side. Okay, we want to combine like terms, so put all the x squareds together, all the x terms together, all the constants together. Okay, so I'm going to leave the left side alone. Okay, so I'm going to find everything with an x squared. So here and here. I have a many x squareds, and then I'm adding b many x squared. So this is going to leave me with a total of a plus b many x squareds. Okay, then I'm going to look at everything that has just an x. There's only one term doing that, or nope, I lied. There's 2 terms. There's the 4bx and the cx. Okay, so I need to add the numbers in front. Here I have 4b many x's, and then here I have c many x's. So I have a total of 4b plus c many x's. Okay, you can also do this by factoring. It's the same thing. If you multiply this back out, you're going to get 4bx plus cx. Okay, so do little checks on yourself. And then what's remaining are just constants. So I'm going to lump these guys together. So a plus 4c is going to be the constant here. And now we can compare to the left side of the equation. Okay, whatever is in front of the x squared on both sides has to be equal. Okay, so this is going to tell us that a plus b has to equal 8. And then what's in front of the x's has to be equal. Okay, so we're going to get that 4b plus c has to equal positive 10. Okay, notice none of the x's are coming along. This is all just about numbers. We're comparing what's in front of the x squared, what's in front of the x, what the constant portion is. Okay, so lastly, just the number, those pieces have to match. So this tells us that a plus 4c has to be equal to -3. Okay, this is a system of 3 equations in 3 variables. So I'm out of room on this page, so I'm going to go to the next page to solve this system of equations. So I'm going to jot everything down. So we have a plus b is equal to 8, and 4b plus c is equal to 10. And then lastly, a plus 4c is equal to -3. All right, so we're going to start solving. Okay, again, we're not going to bother with matrices unless you want to. We're going to do either, substitution or elimination or some combination thereof. Okay, there are several ways to approach this. When I look at the system of equations, I think that the first equation is the simplest. So what I'm going to do is just take it and solve for one of the variables. Okay, so here, if I have a plus b is equal to 8, it doesn't matter which one you solve for. I'm just going to go ahead and solve it. I'll solve it for b. Okay, so I'll subtract the a. This is going to tell me that b is equal to 8 minus a. And then what I can do is use that information in equation 2. So we have 4b plus c is equal to 10. But I just saw that b is the same thing as 8 minus a. so I can make that substitution. Okay, so I've got 4 times b. B is the same thing as 8 minus a. Use parentheses here. You're multiplying by all of b. That's all of 8 minus a. Plus c. That has to equal 10. Okay, and so this is going to give me, if I distribute 32 minus 4 times a plus c is equal to 10. Okay, so if I just kind of clean this up, like put all the numbers on the other side, subtract the 32, this is going to tell me that negative 4a plus c is equal to negative 22. Okay, so this is an equation that just has an a and a c. And if you look at equation 3, it just has an a and a c. So in my next step, I'm going to write down equation 3, and I'm going to line it up with this result. Negative 4a plus c is equal to negative 22. Okay, both of these guys have just an a and a c. B is not even in the equation here. So we can do elimination here. Okay, I'm going to try to multiply by something to make one of the variables go away. Okay, you can either make the a go away or the c go away. It's your choice. Okay, I'm going to multiply the first equation by positive 4. Okay, that way when I send the 4 through, I'm going to have a 4a and a negative 4a, and they will cancel. So I'm going to do that. So I'm going to get 4a plus, you have to distribute, so 16c is equal to negative 12. And then I'm going to leave the second equation alone. And now I'm going to add, so 4a plus negative 4a, those guys will cancel. Then I'll have 16c plus c, that's going to be 17c. And then when I add these guys over here, negative 12 plus negative 22, this is going to be negative 34. If I want c, I just have to divide off the 17. So I'm going to get that c is negative 2, and boom, we have one of the coefficients. Okay? At this point, I can use this information to get the other coefficients. Okay? And it really doesn't matter what you plug into. It just has to be a valid equation that we've encountered along the way. Okay? I don't know, if I go back up here, I see that 4b plus c equals 10. Okay, so I'll use that. So I'll come down here. 4b plus c equals 10. But now I know the value of c. C is negative 2. Pop it in. 4b plus c, that's plus a negative 2, that's got to equal 10. So add the 2 to both sides. 4b has to be 12. Divide off the 4. B has to be 3. There's the second coefficient. Okay, now we just have to get a. Okay, let's go up and see what we can use. Oh, we can use this guy. Okay, right here. We know that b equals 8 minus a, or we can use, maybe better because we just figured out what b is, we need to solve for a. We can use the fact that a plus b has to sum to 8. Okay, so I'll go over here. We know a plus b has to add up to 8. Okay, we know that b is 3, so a plus 3 has to equal 8. Subtract off the 3, a has to be 5. That's the last coefficient. All right, so a is 5, b is 3, and c is negative 2. If I go back to the previous page and I look at my original fraction, okay, I can now write down the partial fraction decomposition for this thing, okay, because I know the recipe. Okay, we wrote down the recipe earlier. Okay, so here we go. We just have to plug in the a, the b, and the c. We just saw that a is 5, b is 3, and c is negative 2. Okay, let me check that. A is 5, b is 3, and c is negative 2. Okay, so we just need to pop these guys in. Okay, follow the recipe in the yellow box. The partial fraction decomposition for 8x squared plus 10x minus 3 over x plus 4 times x squared plus 1 is going to be a, which is 5, over x plus 4 plus b, which is 3x, plus c, which is minus 2, over x squared plus 1. This is the partial fraction decomposition. We have written the original fraction as simpler fractions that we are summing. Okay, you can check yourself by taking the result in the red box, okay, getting a common denominator and simplifying to make sure you get the original fraction 8x squared plus 10x minus 3 over x plus 4 times x squared plus 1. I'll leave you to check it.